Hi everyone. So today we're going to work on our hypothesis testing, but the key here is that we have no idea what the population standard deviation is. So since we don't know, it's considered unknown, which means that we're going to have to use sample. And sample standard deviation goes with the t distribution, not the z distribution. So that's going to be your key. Just like in confidence intervals, when we look at the problem, we're looking for the words population standard deviation. If it's there, that means it's a z. If it's not, it's a t. That's where we have to go. So let's review our t distribution. So if you remember, the t distribution was a family of curves and is dictated about the degrees of freedom. Remember, there are df's. Which was sample size -1. And we have a chart. Okay, the t chart. Okay. Right. So if you remember, this is where we went for confidence intervals. And as we got closer and closer to 30, we're going to be more and more closer to the normal distribution. So anything above 30 is probably going to be our normal distribution. So here, notice that before we used confidence intervals, but now if you look across the top, it says one tail and two tails. And that's where we're going to be. Okay, so oops, my apologies. All right, so let's take a look at how this is going to work. All right, so first thing we're going to do is we're going to do our our hypothesis test using the critical values, not the p-value yet. All right, so again, we're going to start with our level of significance. So let's find our alpha. So that's going to be given to us in the problem. You need your degrees of freedom. And you're going to use the table in the row with n-1 degrees of freedom. Now, you're going to use the one tail or the two tail column. So if it's left tail, you're going to go to the one tail column. You're going to go down to degrees of freedom. And whatever number that is, you're going to make it a negative sign. If it's a right tail, you're going to go to the one tail column or row. You're going to go down until you get to degrees of freedom, and you're going to take that number and you're going to put it on the positive. If it's two tail, you're going to go to two tail column, you're going to go down the number, and you're going to make one side negative and one side positive. Okay, so here's your left tail, your right tail, and your two tail. Okay? All right, so let's try a problem of just going and finding our critical values using our t charts. So we're going to create a critical value t sub o for left tail test, given alpha is 0.05 and we have a sample size of 21. So the first thing we're going to find is our degrees of freedom. So that's going to be 21 minus 1, or 20. So I'm going to go in the row that says 20. We're doing a left tail test. We're going to draw our picture for a left tail. Here's my shaded region. And I'm going to go find this value. Okay. All right. So I'm going to go to the 20 degrees of freedom. So there they are. There. And since we are doing a one-tail test, here's the one-tail row. And my test is 0.05. We're going to come down the 0.05 column. And we're at 1.725. Now we're going to make it negative because we're doing a left tail test. There's your critical value. Okay, let's try the next one. We want to find the critical value for a right tail test at 0.01 with degrees n-1 is 7, n is 17. So you need the degrees of freedom. So our degrees of freedom are 16. Let's move that over a little bit. We're going to draw our picture. Right tail test. Here we are. All right, so we're going to go to the row that says 16. Okay, we're still in the right tail column, a row. Okay, degrees of freedom is 16. Here it is. And we're doing an alpha of 0.01. First of all, that needs to move up. Okay, and we're going to go to the 0.01 column. So, 2.583. So it's on the positive side, we're going to leave it a positive number. Okay, let's try the last one. We're going to find the critical values, T sub O and negative T sub O, for a alpha of 0.05 and n is 21. So we need our degrees of freedom. So we're going to go to row 25. There we are. We're going to go to the two-tail row, and we're going to go to the column for 0.05. There we are. So 2.060. Now when we draw our picture, we're going to negative 2.060 and positive 2.060, and we are sheeting on the right and left of those. So there's your two-tail test. Okay, so this is our rejection regions, our critical values and rejection regions that we're going to use. We're not ready for p-value yet because that's going to be a little bit more difficult than using the chart. Okay, so now that we're able to put together our rejection region, we are ready to talk about the test statistic that goes with a unknown population standard deviation. So because we have an unknown population standard deviation, we're going to use a T. So the only difference in the test statistic is we're using S instead of omega because we don't know, or sorry, sigma, because we don't know our population standard deviation. We're going to be able to have our sample standard deviation. All right? And again, we have our same conditions. It has to be random. Population has to be normal to begin with. And our sample size has to be either over 30. Okay? If our population is normal to begin with, we can be less than 30. All right, so here's all our steps again. Okay, verify it's not known, the sample is random, the population is normal or greater than 30. We got our HOHA again. You got your level of significance. We have our degrees of freedom this time. We have our critical values, rejection regions, our test statistic, and our decisions are the same. If your test statistic is in your rejection region, you're going to reject H sub O and accept H sub A. Okay? And then we're going to interpret exactly the same way. So everything is the same except the formula for your test statistic and where you're going to get your critical values for your rejection regions. That's it. Everything else is the same. All right, so let's try this problem. We have a used car dealer says that the mean price of used cars sold in the last 12 months is $21,000. You suspect this claim is incorrect, and find a random sample of 14 used cars sold in the last 12 months have a mean price of $19,189 and a sample and a standard deviation of 2,950. Is there enough evidence to reject the claim at alpha equal to 0.05? And we're going to assume the population is normally distributed. Okay, how do I know this is a T problem? Is because this standard deviation is from a random sample. It does not say population standard deviation, so keep that in mind. Okay? All right, so let's start with our HOHA. Oh, before we even do that, can we do the problem? It does say random sample, and it does say normally distributed, so we're good to go. All right, so we want to, he says that the price of the mean price of used cars in the last 12 months is at least 21,000. So at least means greater than and equal to 21,000. So our mean price is that. And H sub A is 21 less than. And he's the claim, H sub O. Okay. We're going to state our alpha. 0.05. And while we're here, let's state our degrees of freedom. So it's going to be 14 minus 1, so 13. So that's what we're going to use there. Okay. All right, so let's do our test statistic. Oh, let's draw our picture first. I'm sorry. So let's create our rejection region. Okay. This is a left tail test. How do I know? It's H sub A. Again, remember it's H sub A. So come over here. Okay, so we're using the one tail test because it's left. And I'm going to use my row 13. Okay, there's row 13. And we're looking in 0.05 in a one tail test. So 1.771. And it's going to be negative because it's left. There we go. So we're going to create our test statistic. We're going to compute that, and we're going to see if he is to the left of negative 1.771. Okay, so our test statistic. All right, so the mean was 19,189 minus 21,000. We have a sample standard deviation, 2,950 over the square root of 14. Okay, so let's do some computation. I can't bring up my calculator, guys, because it shuts off my app. So we'll go through the calculator computation, like how to use the t-test on our calculator when I see you again in person. All right, so I got negative 2.297. So I'm going to come over here, and is that to the left of negative 1.717? Yeah, it's all the way over here. There you go. So our decision is to reject H sub O and accept H sub A. There's our decision. All right, so let's write our conclusion. Okay, so we don't have a p-value yet because we haven't talked about that. So we're just going to start with there is enough evidence. There is enough. Okay, I don't need this anymore, so let's get rid of that. Enough evidence to, okay, so we're going to reject the claim. That the mean price of used cars sold in the last 12 months is at least 21,000. Wow, I wrote really big there. Let's try that one more time. So we're going to be able to have a type 1 error here. Okay, so I'm going to call it here. There is another problem here if you want to try it on your own. But if you notice, all the steps are the same. The thing that's different is that we have to include our degrees of freedom to create our rejection region, and our test statistic is using pretty much the same formula, but we're using S instead of sigma. All right, guys. If you have any questions, please let me know. And again, please stay safe out there, and I'll talk to you again soon.